camera, today I'm going to talk about Kepler's law of planetary motion. First, what is ellipse? So first, what is ellipse? So we know what is circle, right? Circle have a radius, right? That all points at the circle to the center have the same distance, and it's the radius. But ellipse is different. Ellipse is a little flatter. Okay, so there's two foci or two focus. So any point on the ellipse and this distance to the first foci to the second distance to the second foci plus together is always equal to the same number. So first, let me introduce some things. First, the center. Center is just the center, of course, and the focus is just the two focus. And the major axis is the long one, or this one, the long one, or you can say if it's this one. So it's always the long one. And the minor axis is the shorter axis, okay? The semi-major axis is half of the major axis, you can represent as A. And semi-minor axis is half minor axis, or you can represent as B. First, what is eccentricity? A shape of ellipse is measured in eccentricity, is how flat, okay? So if something is close to a circle, its eccentricity is very small. So circle's eccentricity is 0. Ellipse eccentricity is greater than 0, okay? Okay. And another ellipse introduction. So first, if this is an ellipse, okay, and we draw a cross sign like this. Draw a cross sign, and this x-axis is the y-axis. Okay, so we found maybe this point, the x squared over the a squared plus the y squared over the b squared is always equal to 1. Okay, and another thing, remember that the d1 plus d2 is this plus this is always equal to the same rate, the same number. So what is the number? So first, let's see this, okay? Okay, so first, so this is an ellipse, okay? So this, okay. So first, let me see any. Okay. Okay. So first, maybe a point right here. Wait a second. Okay. Okay. Point right here. So the first distance is this, and the second distance is this. So if you plug them together, you found is just the whole major axis, or you can say it's 2A, two semi-minor axis. Okay, a semi-major axis, or 2A, or just a major axis. Okay. So first, what is heliocentric and geocentric? Okay, so in the 16th century, most people believed that the planet, the moon, and the sun all orbit the Earth. But in 1543, people named Copernicus proposed the idea that all planets and the Earth orbit the sun. However, the theory was too clear about the fact. So half century later, people named Kepler used the observation, and he used his mentor tackle and things, and then he made his own theory. Okay. Kepler's first law. So Kepler's first law. So earlier theory of solar system, like Copernicus said that all planets include the sun, about all planets include the Earth orbit the sun, but he said in perfect circles. But Kepler said that is in ellipse, not instead of perfect circle. Sun is the one of the focus or foci. Okay. So first we'll see what is 1 AU. 1 AU is the average distance from the Earth to the Sun, or you can say it is 1.5 times 10 to the 11th power. Kepler's first law. So first we know what is this. First, you can see the eccentricity, and can show the empty focus, show the center, show the semi-minor, and show the red line. And you can show a lot of things like this. But now I don't want the ellipse, nothing, and I don't want to show the card. Yes, but I am choose Mercury, for example. Okay, just Mercury. Yes. Now it is Mercury, and it can also. So first start animation, so you can see different speed. And when it got very fast, it's very fast. Okay, stop. So you see some empty focus. Is this? So some is one of the focus, and it have eccentricity right here. That means it's orbit in ellipse. Okay. Okay. Another. Kepler's second law. What it is said? So he said that Kepler's second law said that when planets close to sun, it gets faster than when it moves away from sun. So it swoops for equal areas, okay, in the same time and same speed. So for example, when I still choose Mercury, for example, start. Okay, and start swapping. Okay, so when it gets close to the sun, you found it's very fast. Okay, so another thing you guys know. So for example, now you see it's very thin, but when it moves, it gets very fat. So you can see it is the same time, because when I move from here to here, it's become thinner, thinner, thinner. So then this area is equal to this area, because when we move it, we found it. Okay? It's that last law. What is that law said? So he said that the square of the orbital period over the cube of the semi-major axis is always the similar number. It's always close to 1. So the P2 is the time for the orbit to get 1 square over the semi-major axis or semi-major axis cube is always close to 1. So 1.002, 1.002, 1. Just 1, 0.999, 0.999, 1.001. Okay, so thank you, bye bye.